All right, so what I'd like to discuss with you guys is I want to kind of go back a little bit to some of the things we've talked about, all right? And the way that I'm going to describe this is what we're going to do is we're going to talk about the discriminant, okay? So what you guys can just write in is the discriminant. Yep. Yep. That was the un sheet de papel for notas? Notes? Oh, okay. No, that's going to be separate. You guys are going to be working with that in a second. So I want you guys to find the discriminant, all right? And what the discriminant is, if you guys ever remember learning about your square roots and squaring, the discriminant is what you're going to be taking the square root of, all right? But before we get into what we're taking the square root and where a square root even comes into, when we're going to be talking about the discriminant for right now, we're going to be talking about this equation, or this expression, b squared minus 4 times a times c. All right, so this is what we're going to call the discriminant right now, even though I know the discriminant is what you take the square root of. Now, we will be taking the square root of this number here in a second, so it's very important for us to understand how to evaluate this. Now, first of all, you might ask, well, what are your a, b, and c, right? Or your b? Remember, these are all going to stem from your quadratic equation. Okay, so whenever you have a quadratic equation, you can be able to determine your b squared minus 4 times a times c. All right? Yes. Your a is going to be your coefficient of your x squared. Okay? All right, is everybody following me right now? Yeah. Okay, so why are we going to want to find or determine the discriminant? What is the discriminant going to tell us? All right? Well, there's a couple things the discriminant's going to tell us. When our discriminant, well, we say b squared minus 4 times a times c, when that equals 0, okay? So whenever you take your a, b, c, whenever you take these numbers and you square, then multiply by 4 times a times c, when you have that equal to 0, your quadratic, your parabola, is going to have one real solution. So if you guys remember we talked about factoring, and we talked about finding the solutions of a quadratic, right? We could only do that by using inverse operations and factoring. And then there was that one time when we looked at a graph where it had one real solution. That means where it touches the graph and kind of rebounds, which the graph would look something like this. Right? If it only touches the graph but does not cross, there would have one real solution. So let's go and take a look at another one. What about if you have b squared minus 4 times a times c? Let's say it's greater than 0. So that means it's a positive number, and it's a square number. So what does a square number mean, right? What if this number is 1, 4, 9, 16, 25, 36, 49, 64. You guys know the pattern, right? Hopefully. So if it's a square number, since we're talking about the discriminant, since you're going to be taking the square root of this, the square root of square numbers is going to give you what kind of numbers? Anybody want to make a guess? Prime. Close to prime. It will give you some prime numbers, but it's also going to give you rational numbers, right? Numbers that can represent fractions, or in this case, actually, this is going to actually give you integers, but then our answer is always going to be rational. So what we'll have is we'll have 2 real rational roots. All right? So if you have your square number is greater than 0, but it's a square number, then you're going to have 2 real rational roots. And then let's say, what if you have b squared minus 4 times a times c is greater than 0, but it's not a square number? So that means it's all numbers that are not going to be square, right? So numbers you are not square, that means you cannot take the square root of them, right? Let's look at 13. Can you take the square root of 13? Are there 2 numbers that multiply to give you 13? No. So when you can't take the square root of a number, that provides what type of number do we have? Rhymes with irrational. Irrational, right? So therefore, you're going to have 2 real irrational roots. And what does irrational really mean? Can you still graph irrational numbers? Yeah, you can. However, irrational numbers just means you can't write them as a fraction, and they are going to go on and on forever. So you are going to be approximating them. All right, if you try to find the value, if you plug in the square root of 13 in your calculator, there you give you a decimal as an approximation. All right? And then we have our last one. What about if you have b squared minus 4 times a times c is less than 0? Okay? Doesn't matter if it's a square number, non-square number, but if it's less than 0. So let's think about this. I told you this is the discriminant, meaning you're going to take the square root of this number, right? So if you take the square root of a negative number, can you take the square root of a number, a negative number? No, right? But we learned how to take the square root of negative numbers by using the what number system? Imaginary number system. And so what we'll have is complex numbers. Imaginary numbers are a part of complex numbers. So therefore, what we're going to have is 2 complex roots. Okay? So if your discriminant, which you find, is going to be 0, all right? If you find it to be 0, what you'll have is 2 complex roots. Okay? Cool? All right. Oh my God, I forgot to go over their homework for you guys.